Hello guys, welcome back. Today we are continuing with probability. I have a question here that says, at a college, the students choose exactly one of tennis, hockey, or netball to play. The table shows the numbers of students in year 1 and year 2 at the college playing each of these sports. So then you have this table with all the data relating to this information here. So one student is chosen at random from the 120 students. That means all these students, if you add up all these numbers, n is equal to 20. That is the number of the sample size. That is our sample size. So events X and N are defined as follows. The event X is that the student is in year 1, and event N is that the student plays netball. Then you are required to find the probability of event X happening, given that you have N. So what is the probability that the student is in year 1, given that they play netball? So this is conditional probability. So we say the probability of X given N will be equal to the probability of X intersection N divided by the given probability, which is the probability of N. So we need to find the probability of X intersection N. So the probability of X intersection N, X is that they are in year 1 intersecting, they like netball. So year 1 playing netball, that's 12 over 120. So that will be 12 over 120 divided by, which means I'm going to multiply here, but I'll inverse the other probability. Okay, so remember, 12 over 20 is the probability of the intersection. And then I'll say multiply by the probability of N. N is the student plays netball. So how many of them play netball? So the students that play netball would be 28 plus 12, which is equal to 40 over 120. So if I inverse 40 over 120, I get 120 over 40. Okay, then you just plug this in your calculator. That will be your probability. So if I plug this in my calculator, I get a probability of 0.3. That will be my probability, 0.3. Okay, the next question says, find the probability of N given X. Okay, we have just changed N and X here. So we're saying the probability of N given X. So this will be the probability, once again, of N intersection X divided by the given probability of X, which will be, again, the intersection remains the same. So obviously this is remaining 112 over 120 multiplied by, now I need the probability of X. The probability of X, I didn't calculate it earlier on, isn't it? X is that the student is in year 1. So I need to add all these numbers, 16, 22, 12. Add all those numbers to get your probability. So that's going to be 16 plus 22 plus 12. That gives you 50. And then that will be 50 over 120, but you inverse it so that you can multiply. So that's going to be 120 divided by 50. And this will give you, if you just plug that in your calculator, fraction button 12 over 120 multiplied by 120 over 50, that gives me 0.24. So I'll get 0.24 here as the probability. Then we move on to the next question. The next question says, determine whether or not X and N are independent events. So this is test for independence. So I'll say these events are independent if the probability of the intersection of the two is equal to the product of the probabilities. We know the probability of the intersection, we know it, we just calculated it, right? It's 120. So we're going to say one intersection is 12 over 120. So this must be equal to the probability of X, which we just calculated to be 50 over 120, and then multiplied by the probability of N. The probability of N, if I just scroll up, N will be that the student plays netball. If they play netball, that will be 12 plus 28. So that's 30, 40. So that will give me 40 over 120. Okay, so multiplied by 40 over 120. Okay, which will equal, when you multiply that, let's see what that gives you. So that will give you 5 over 36. 5 over 36. So clearly, 5 over 36 is not the same as 12 over 120. If you simplify 12 over 120, you're going to get 6 over 60. So clearly, these are not the same things. They are not equal. So you can just say they are not equal. Therefore, the events are not independent. So I'll say, therefore, X and N are not independent. Events X and N, write in full here, and N are not independent. Okay, so as we have seen, the events are not independent because, of course, 12 over 120 is not the same as 5 over 36. Even if you simplify 12 over 120, they are not the same. So let's move on to the next question. The next question says, one of the students who plays netball takes 8 shots at goal. On each shot, the probability that he will succeed is 0.15, independently of all other shots. Find the probability that he succeeds on fewer than 3 of these shots. Okay, so looking at this question, I think it's they've combined topics here. This is one of the topics that we are going to do in the future, which is binomial distribution, when we look at probability distributions. Why do I say that? We have a fixed number of attempts, which is 8, and we have a fixed probability of success. On each trial, the probability of success remains 0.15. That means the person who is shooting, the person playing netball, they are not learning after every attempt. They are not improving after every attempt. So if their probability of success now is 0.15, their next shot is still 0.15. Their 7th shot is still 0.15. Their 8th shot is still 0.15. They are not learning. This is binomial distribution. So if we were to answer this, I'll use a different color pen here. We would say X follows a binomial distribution with parameters n being 8 attempts, and probability of success 0.15. Okay, it's important that you understand that. So P is your probability of success. It's equal to 0.15. Then Q is your probability of failure, which is 1 minus 0.15, which is 0.85, right? So the binomial formula says that n choose R, then you have probability of failure here. I'll say to the power of n minus R, and then your probability of success to the power of R. So if I look at the question, it says find the probability that she succeeds on fewer than 3 of these shots. So she's going to take 8 shots. And what is the probability that she is not going to be successful 3 times or more? So that means probability of, I'm looking at the probability of X, random variable X, where random variable X is the number of successful attempts. So I want this to be less than 3. So that means she can shoot all 8 attempts and not be successful. Or she could shoot all 8 attempts and be successful once, or she could be successful twice. That's how we write it. And then you can then say, if she's unsuccessful on all 8 attempts, it means she failed all of them, all 8. So that's 0.85 times 0.85 8 times. So that's 0.85 to the power of 8. And then plus, I'll use the formula. The formula n is 8 here. So I'll say 8 choose being successful once, multiplied by the probability of failure, 0.85 to the power of n minus 1 is 7. So 0.857, that's 7 failures. And then multiplied by probability of success to the power of R, which will be 0.15 once, success once. And then plus 8 choose 2, multiplied by 0.85 to the power of 6, that's n minus 2, multiplied by 0.15 to the power of 2. Plug it in your calculator. The answer that you get will be equal to 0.895. Okay, so that will be the probability, but this is something that we are going to do in a future video. Right, we move on to the next question. The next question, again, is about probabilities. It says that a sports event is taking place for 4 days, beginning on Sunday. The probability that it will rain on Sunday is 0.4. On any subsequent day, the probability that it will rain is 0.7. So after Sunday, the probability that it will rain is 0.7 if it rained on the previous day. So there's a conditioning. So if it rained on the previous day, then the probability of it raining today, if it rained yesterday, will be 0.7. And 0.2 if it did not rain. So the chances of it raining if it didn't rain yesterday is 20%, 0.2. Okay, so I think I can do a tree diagram, but it seems to be a crazy one. This is going to be a crazy tree diagram because from Sunday for 4 days, that'll be Sunday, Monday, Tuesday, Wednesday. So that's from Sunday to Wednesday. Okay, if you want, you can do a tree diagram, but I'll show you. I think there should be an easier way. If I do Sunday, so here's my tree diagram. So this is the first day. Okay, let me write here. Or I'll write afterwards. Let me just see how we can draw the tree diagram. So this is Sunday. And then this is Monday. You see, this is Monday. And then this is Tuesday. Monday, Tuesday, right? Tuesday. So Tuesday will be this one. And then Wednesday, which is the 4th day. This is how your tree diagram is going to look like. This is the tree diagram. So yeah, it's a crazy one. Like I said, this will be Sunday, Monday, Tuesday, and Wednesday. And then they say find the probability that, so you can populate this. So on Sunday, the probability of it raining, if this is rain complement. So the probability of raining is 0.4. The probability of not raining will be 0.6. This one is rain complement. Then now conditions start. It rained yesterday. So the probability of it raining now is 0.7. Okay, that means the probability of not raining is 0.3. This will be rain and rain complement. But it didn't rain yesterday. If it didn't rain yesterday, the probability that it rains this today is 0.2. So that means this will be 0.8 and so forth. So you keep going with this tree like that. So that means also on Tuesday, if it rained on Monday, this remains 0.7, the probability of rain. This is 0.3. This is rain complement. You see, you keep going like that. So if it didn't rain, this will be 0.2, 0.8, right? If it, that is rain and rain complement. And then here we have rain and rain complement. I did complement where I shouldn't. This one is not complement. It's just rain, isn't it? I made a mistake there. So like that. So you keep going, but I'm not interested in this really because it looks crazy, but it works. So I could say it rained yesterday here, so the probability of it raining is 0.7. The probability of rain not raining is 0.3. It didn't rain yesterday, so the probability of raining here is 0.2. The probability of it not raining again will, of course, then be 0.8. So you keep doing this. And knowing I have Monday, Tuesday, Wednesday, Sunday, Monday, Tuesday, Wednesday. So you could do it like this. And then to answer the question, they say find the probability that it does not rain on any of the 4 days of the event. So that means no rain, no rain, no rain, no rain 4 times. That would be the bottom branch, isn't it? So the bottom branch is when we don't have rain, and then we don't have rain, we don't have rain, we don't have rain. So if you see, it's going to be 0.6 multiplied by 0.3, 0.8 multiplied by 0.8. This one is also going to be 0.8. So that's how you answer. You can draw this tree diagram and use it for all the questions that they are going to ask. But I wouldn't draw a crazy tree diagram like this. I think there is a better way of just thinking about things, and then you can solve the question that way. Okay, let me just erase all this then. And then let's look at it from a different angle. Right, so we know that they are asking for the probability. So I want the probability that it doesn't rain on the first day. So no rain, rain complement on Sunday. Then I want rain complement on Monday. Then I want rain complement on Tuesday, rain complement on Wednesday. These are 4 days. So this is what I'm looking for. The probability of it not raining on Sunday is 0.6 because the probability of raining on Sunday is 0.4. It didn't rain on Sunday. So the probability of it raining on Monday will be 0.2, which means the probability of it not raining on Monday will be 0.8. But from there on, the probability of it not raining when it didn't rain the previous day, that probability doesn't change. So that means that on Tuesday, it's also 0.8, not raining. On Wednesday, it's also 0.8, not raining. Then you just plug this in your calculator. So if I put this in my calculator, I have 0.6 times 0.8. I'll say to the power of 3, because it's to the power of 3, isn't it? That gives me 0.3072. So I'll say this is 0.31. That's what I'm getting. Okay, we move on to the next. It says, find the probability that the first day on which it rains during the event is Tuesday. The probability of it raining first on Tuesday. Okay, so probability of no rain on Sunday, no rain on Monday, but I want rain on Tuesday. This is it, isn't it? No, there's no other way. So this is going to be probability of it not raining on Sunday, which is 0.6. We just did that. Probability of not raining on Monday will be 0.8. Probability of it raining on Tuesday, given that it didn't rain yesterday on Monday, will be 0.2. You see? So I must just say 0.6 times 0.8 times 0.2 equal to, that gives me a probability of 0.096. Okay, so that's what I get. Okay, so we move on to the next one. It says, find the probability that it rains on exactly one of the 4 days of the event. Okay, so this one you could go back and use the tree. if you drew that crazy tree that we had earlier on. Or you could just use scenarios where we say the probability of it raining one of the 4 days. That is, it could rain on Sunday. So I'll say probability of it raining on Sunday and not on any of the other days. So this one will be Monday, isn't it? Monday. And then no rain again on Tuesday, no rain on Wednesday. Right? So this one is Monday here. So that is the first situation. Or I can just then keep shifting that rain one day, one day, one day. So I shift it by day. So this no rain on Sunday, and then rain on Tuesday, no rain on, oh, I want to say rain on Monday. I keep confusing this. And then no rain on Tuesday, and also no rain on Wednesday. Okay, like that. That's another condition. And then I can have no rain on Sunday, no rain on Monday, but rain on Tuesday. And then still no rain on Wednesday. And then I could have no rain on Sunday, no rain on Monday, and then I could have no rain on Tuesday, and then rain on Wednesday. You see, this could happen, like so. And then now you want to find the probabilities. So these probabilities, you go back to the question, listen carefully to what they said. They gave you conditions. The probability of it raining on Sunday is 0.4. So we say 0.4, that is the probability of it raining on Sunday. And then the probability of it not raining on Monday, given that it didn't rain or it rained on Sunday. If it rains on Sunday, the probability that it doesn't rain the following day is going to be 0.3 because the probability of raining is 0.7. So I'll multiply this by 0.3, which is the probability of rain complement. Remember, let me explain. If it rains today, the probability that it rains again tomorrow is 0.7. That's what they said. So the probability of it not raining tomorrow is 0.3. So it rains on Sunday, therefore the probability of not raining on Monday is 0.3. But if it doesn't rain on Monday, which is 0.3, the probability of it raining on Tuesday is 0.2, meaning that the probability of it not raining on Tuesday is 0.8. You see? But if it doesn't rain on Tuesday, the probability that it doesn't rain again on Wednesday will remain the same. So it will be again 0.8. You see, these are your probabilities. And then we want to look at the probability of it not raining on Sunday. This is 0.6. But if it doesn't rain on Sunday, the probability that it rains the following day is 0.2. They told us the probability of it raining, if it didn't rain the previous day, will be 0.2. So this is going to be times 0.2. And then you multiply that by the probability of it not raining. Where are we? We are on Tuesday now. So it rained on Tuesday. So therefore, the probability of it not raining on Tuesday is going to be 0.7 minus 0.2. 0.7, 1 minus 0.7, which is 0.3. Why do we say that? Because it rained on Monday. So the following day, it must rain. It's 0.7 chances. But we don't want rain. We want the probability of it not raining on Tuesday. So this will be 0.3, not 0.7, 0.3. You see? So, but if it doesn't rain on Tuesday, the probability of it not raining on Wednesday is increased. It's now 0.8. Then we go to, this is a little bit confusing, so you can just use the tree if you drew that crazy tree. But the probability of it not raining on Sunday is 0.6. It didn't rain yesterday, which is Sunday. Today is Monday. So the probability of it not raining on Monday, given that it didn't rain yesterday, is very high. It's 0.8. Chances are it's not going to rain. Right? And then now it didn't rain on Monday, sorry. We now want the probability of it raining. It's 0.2. We said this, the probability of it raining when it didn't rain is 0.2. But it didn't rain on Tuesday. So what is the probability that, which one are we doing? Oh, the probability that it rains is 0.2. So if it rains, the probability of not raining is going to be 0.3 because the probability of raining is 0.7. So I'll say this one is 0.3. Okay, I hope you can sit down and think about this yourself. Okay, so not raining on Sunday is going to be 0.6. Not raining on Monday, given that it didn't rain yesterday. So the probability that it doesn't rain again is 0.8. Chances are high. Then, if it didn't rain on Sunday, it didn't rain on Monday, the probability that of it not raining again is still very high, it's 0.8. But if it didn't rain on Tuesday, the probability of it raining on Wednesday is going to be 0.2, raining on a day after the day that it didn't rain. Okay, so just calculate those numbers. You should get the ones that I have there in green. And then if we add those numbers, we just say this will be equal to 0.0768 plus 0.0288 multiplied by 2, or I forgot to multiply it by 2 because it's the same number. But you can just add it again, 0.0288 plus 0.0768. And then if you add this, just put this in your calculator, 0.0768 plus 0.0288 by 2 plus 0.0768 equal to, then that gives you 0.2112. Okay, so that will be that. Okay, guys, so let's look at the next question. The next question says, Freddy has 2 bags of marbles. Bag X contains 7 red marbles and 3 blue marbles. Bag Y contains 4 red marbles and 1 blue marble. Freddy chooses one of the bags at random. A marble is removed at random from that bag and not replaced. So no replacement. Okay. A new red marble is now added to each bag. So to each bag, not just that bag, but each bag. A second marble is then removed at random from the same bag. That is, a second marble is then removed from the same bag that the first marble had been removed from. Okay. Draw a tree diagram to represent this information, showing the probability on each of the branches. Okay. They want us to draw a tree diagram. Okay, so if I'm to draw a tree diagram here, I have a tree diagram for the choosing the bag. So you might choose bag X or bag Y. You could say, I'll write it like this. I'll say bag X and bag Y. Right? If you choose bag Y, then there are 2 things that could happen. You could have, for the first pick, you could pick a red marble or you could pick a blue marble. Right? You see, it says Freddy chooses one of the bags at random. That is the first branch, the first 2 branches, that first branch. The marble is removed at random from that bag and not replaced. A new red marble is now added and the second marble is picked. So for you to pick a second marble, that means I need another branch. So I need this. That is the second picking. The first picking from bag Y will look like this, red and blue. But I could pick again because we have 2 pickings. So this is what could happen. But when you pick again, the options are you pick red or you pick blue, you pick red or you pick blue, you pick red or you pick blue, you pick red or you pick blue. Now I just need to populate my probabilities. Let's look at choosing between 2 bags. That's 0.5. That's 50% probability of picking each bag. Now, if you pick for the first time from bag X, what is the probability that you pick red? The total number of marbles in bag X is 3 plus 7, which is 10. To pick red, it's going to be 7 over 10. 7 over 10 is 0.7. So I'm going to say 0.7. I'm just going to work with decimals. So that means picking blue is going to be 0.3. Okay. Right. Let me finish that branch. Should I? No, let me do the bottom up. They say if you pick from bag Y has a total of 5 marbles, 4 red, 1 blue. So if you want to pick red, that's going to be 4 divided by 5, which is 0.8. So this is going to be 0.8. That means this is 0.2. Okay, so let me go back to the top branch, picking from the bag X. So if you pick the first marble, you don't replace it. That means out of the 10 marbles in bag X, now you're left with 9. But if you follow the top branch, you picked out of 7, so you removed a red. So now you have 6 reds out of the 9. But then they say, after picking, a new red marble is now added to each bag, which means you reset. You go back to 10. But when you reset, you only use red marbles. So instead of having 9 red marbles, you now are back to 10 marbles. And the fact that you have picked red earlier on is not going to affect you because you are replacing it. So I'm going to have 7 red marbles again. So this is going to be 0.7. If I had picked red in the first instance, and then I replaced it, then I reset from 9 back to 10, but with 7 reds again, what is the chance of me picking blue again? That's still going to be 0.3. Now, let's say you had picked blue on the first pick. Your marbles gets to 9. And then you reset by adding a red ball, right? So the red marbles were still 7. So you still had 7 red marbles. Then you added 1. Red marbles are now 8, but you reset back to 10. So that means now you have 8 out of 10, which is 0.8. Meaning that because I had 3 marbles, which are blue, when I removed the first blue marble and I didn't replace a blue, that means now I'm left with 2 marbles out of the 10 after replacing with a red. So this is going to be the situation. Now you move to the blue bag. If you pick red from the blue bag, you are going to have 3 out of 4 red marbles after picking the first one, because there are 5 in total. You pick red, you have 3 out of 4. But now they say you reset by adding a red marble. So that's now back to 4 out of 5. You see? So if you want to pick red again, the probability is still going to be 0.8 because you are resetting after picking the red marble. So that means picking blue after picking red doesn't change. It remains 0.2. But if you had picked, in the first instance, you had picked a blue marble, that means you had 4 marbles of which none of them were blue. Then you replace with the red, you go back to 5. Okay? But all these 5 are now red. Do you understand that? So now all these 5 are now red. So what is the probability of you picking a red after you replace? That's going to be 1. The probability that you pick a blue for the second time in bag Y is going to be 0. Because after you remove the first blue, you replace with the red. So there's no more blue marbles in that bag. So this is the probability. This is the tree diagram for this situation. Okay, so we move on to B. B says, find the probability that both of the marbles removed from the bag are the same color. Both of them are the same color. So it could be, there are 2 situations where this can happen. You could have, so I need the probability of picking blue and then blue on the second picking. Or it could be that I pick probability of picking red followed by a red, isn't it? This is what I'm looking for. So probability of picking blue, then blue, we just look for the branches that give me blue and blue. So blue is, I picked blue and I want to pick blue. Okay, that's not the branch. That one is red, blue. So I want blue, blue. So that's this one. Blue, blue again is this one. So these, I want these 2. So that's 0.5 times 0.3 times 0.2. Okay, and then I'll add 0. Okay, this one, the bottom one is just going to be 0 because I was thinking about that. When you say 0.5 times 0.2 times 0, you're still going to get 0 because this is not going to happen. So the only branch I need to consider is the top one, the 0.5, 0.3, 0.2. So this is going to be 0.5. This one is going to be 0.5 times 0.3 times 0.2. Okay? Plus the probability of picking red. The probability of picking red is going to be, what color pen I should use? Picking red, then followed by red. So that's the top branch, red, red. So that works. I pick red and then I pick red. Now I need another situation that gives red, red. That would be this. So I have 0.5 times 0.7 twice, which means 0.7 times 0.7. So here, down here, I will say 0.5 multiplied by 0.7 twice. Okay, but I need to add the other situation. So the other situation is that I have 0.5 multiplied by 0.8 multiplied by 0.8. So this will be 0.5 times 0.8 twice, which means square. Okay, these are the 2 situations. That gives me 0.595. So all this gives me 0.595 as the probability. So that's what I get. Okay, we move on to the next question. Find the probability that bag Y is chosen given that the marbles removed are not from the same color. Okay. I have here, this is important, given that this tells me that this is a conditional probability. So I have to read the question again. Find the probability that bag Y is chosen. So probability of choosing Y, given that the marbles removed are not the same color. So that means given, I'm going to call it SC, same color complement. They are not the same color. This will be equal to the probability of choosing Y intersection not the same color okay, divided by the probability of choosing not the same color, right? Let's look at this. When do you not choose the same color? When do you not choose the same color in Y? So you choose Y, and then you don't choose the same color. What color should I use here to show what I want to show? Let's hope this will do. So you choose big Y, but you don't want to show the same color. So it will be this one here. Okay, so red, blue, or blue, red. So these two. This is when you choose big Y and you don't show the same color. So it's going to be 0.5 times 0.8 times 0.2 plus 0.5 times 0.2 times 1. So the intersection is that you pick 0.5 multiplied by 0.8 multiplied by 0.2. This is the top branch. Then you add. This could also happen when you pick 0.5, then 0.2 multiplied by 1. I'm not going to write 1. So it's going to be 0.5 times 0.2. 0.5 multiplied by 0.2. Okay. Just confirming I have everything correct. 0.5, 0.8, 0.2, 0.5, 0.2. Okay, so I have everything right. Then I want the probability of not picking the same color. I have already calculated the probability of picking the same color. It's 0.595. So if I want the probability of not picking the same color, I can just say 1 minus this probability. This will give me 0.405. 0.405. So that means the probability of not picking the same color is 0.405. I'm using complementarity here to say I know already the probability of picking the same color. So the probability of not picking the same color is 1 minus the previous calculation we did up there. Then I'll know what is the probability of not picking the same color. So I can just plug this in my calculator. In my calculator, I'm going to have 0.5 times 0.8 times 0.2 close bracket, and then I say plus 0.5 times 0.2, and then I close the bracket. Down here I have 0.405. That gives me a probability of 4 over 9. So my probability here is 4 over 9. Okay, so that's the probability that I get. Okay, we are done. Okay, so we are done with probabilities. If you have any questions, once again, you're more than welcome to contact me on my number, be it chemistry, be it physics, biology, statistics, pure maths, mechanics. Contact me.